In the first video of this series, we kind of show the wish list of the things that we want the next version of QRadar to have. And when we talk about cloud native, we spoke about searches. And well, it's actually, this is from the QRadar suite. This is login sites, and this is the UI. It is actually everything can be accessed from that hamburger, and you go to the different components, and more on that on this series of videos. I'll give you a good tour of everything that is available so far. So if we go into the searches, what is it that makes these searches peculiar? We're going to talk a little bit about AQL, but let's talk about performance, because we said that we want to have searches that perform extremely fast. And even though this is a very modest instance that I have on the cloud for my demo here, when we look at the searches of these things, we're talking about getting 10,000 records in 237 milliseconds. So things are, very, very fast. How can this be achieved? Again, don't focus on the KQL. I have a whole series of videos that talk about it. But let's talk about the performance. So let's talk about different databases. Traditional databases, relational databases, what makes SQL and all that powerful, is the fact that the data is stored by records. So for example, if I have, think of this as, let's say that I have my database grouped by user IDs, then I'll have all the data for that specific user ID, in the same row, right? And that's what these are called row-oriented databases. And why this is important for performance, this is when you do I/O on a system, you do those things by blocks. I mean, you don't go into a system and to a disk and say, well, give me a byte. No. When you perform a SIG, there's going to be a whole bunch of data, whether you want it or not. What you do with it or not, or don't do, is irrelevant. You're going to get that block of data with you. And the data that you'll get, because the data in a relational database is arranged by rows, you're going to get, these and a whole bunch of other rows in there, right? And what happens is that if you are looking about any particular data about a particular user ID, you're going to get it very fast. But is that the way that we search in security? No. The way that we search in security is typically the other way around. We search, give me all the source IPs that had gone to this specific URL, right? So again, you can achieve similar levels of performance if you were to index everything on the relational database, but then the size of your database becomes very strong. And again, on the performance side, that is actually not a very good idea. And that's what has given place to the technology of C database, or column-oriented database, in which the data is put on the disk, by columns. Therefore, when you perform searches like we do in security all the time, that are column-oriented, you're going to get better performance, and the size of the database, because of the number of indices that you need to put, is actually much better. On top of that intrinsic advantage, the fact that the database that IBM selected, which is called ClickHouse, is not only a row-oriented database, but also it is built on top of OpenShift. And this is, if you have read about OpenShift, Kubernetes, this will give it the dynamically capability of giving resources as the search becomes more demanding, and you get those processes being growing and shrinking with demand. And that is a combination that is particularly good. Now, what is the third aspect of what IBM, in my view, what IBM has done on the searches on login site, which is the subsequent version of QRadar? That has to do with the language itself. KQL is a language that was invented by Microsoft. This Custo query language, which is to me strange, because apparently they did it on, remembering Jacques Cousteau, but Cousteau is with C, no, but K, whatever it is. So I guess that CQL sounds more like SQL or SQL, so I guess that they chose the K for that. God knows. I digress. So the important thing is that if you remember AQL statement or SQL statement, the syntax is not very oriented to be understood. Even, if it's very hard to understand the logic in front of a search that you see in SQL with nested SQLs on one to another, that stuff is it's not very intuitive. At least I don't find it quite intuitive. On the contrary, what IBM did in selecting KQL, and they implemented for the first time, as far as I know, nobody else has done the combination of KQL and ClickHouse. What this does is bring something that security professionals have loved for a long time, which is this concept of pipes. So, and for example, from the events database, instead of select asterisk all, whatever it is, well, you say, well, from the events database, pipe all the events, and then I'm doing, for example, this statement, project. So only get the columns that has a timestamp, the data source name, and so on and so forth. And then do filtering where the events are, 5 minutes ago. And then this tag is last, equivalent to last in SQL. So this statement is more English-like. It's more, okay, if I understand this line, what this line is doing, okay, I know that the results from that are going to be passed along, like you do in pipes in Unix and in any networking. So all of us that have been doing piping are inclined to understand this far better. Now, I have made a playlist. And here on the playlist, there's a playlist called ClickHouse, right? Let's go back to the videos, in which, and all these videos are a few minutes long, right? You can sit down and in the morning, you can understand KQL. I can assure you that's not going to happen with SQL. And you can understand when you watch, and I've done videos on SQL before, but this is will not be, you kind of need to relearn SQL every time you want to do a new search. You'll see that doesn't happen with KQL. It's far more intuitive and easy to follow. And again, this playlist is made to facilitate that process for you. So with KQL, with ClickHouse, which is a raw-oriented database, and with the capabilities of OpenShift for shrinking and growing of the infrastructure, you got great performance. And think of login sites as a data lake, but with security in mind, where all the things are parsed and treated and indexed as severity, categorized, etc. So it is actually very easy to make incredible, fast, and intuitive searches on it. But there is another problem when we talk about cloud natives, and it's the ugly egress charges. You see, all these cloud providers, they are like kind of a Hotel California. It's easy to check in but hard to check out. So whenever you put data in it, oh, welcome. Yeah, we're not going to charge you for that. Why? Because you already pay for the infrastructure to get that data there. But when you get data out, then these things come and bite you. And some people have found these nasty surprises when they get the billing from the cloud providers on those ugly egress charges. What is it that IBM has done to work on that? So if we go to this unified interface that IBM has put here on the searches, and we look for the type of searches, notice that we have 3 types. One is I can make calls into QRadar. That's cool. And this is good to make it easier for people to leverage their investment on QRadar today with things on the cloud, like with login sites. But also is this federated sticks searches. So what is the concept here? Well, let's say that you have an EDR solution, right? And I'm going to use, it can be any example, but say that is CrowdStrike. Well, you're going to have agents. Let's say that you're running CrowdStrike on a cloud, right? Well, you're going to have agents on every one of those machines on the cloud that are going to be generating a tremendous amount of telemetry for everything that is happening on the kernel, and that's how EDR can figure out what the heck's bad actually happened. But if you have QRadar either on-prem or on another cloud, and you were to send all those events from cloud A to cloud B, or from cloud into on-prem or whatever, those egress charges are going to bite you, and are going to bite you big. The concept of these federated searches is to say, well, I'm performing a search, but what I'm going to do is I'm going to ask that EDR technology, give me, for example, all the places, all the URLs where a particular source IP has actually gone on the last, 2 days. So whatever is the data that you want, or all the processes that have been spawned by this particular MAC address, or whatever is the data that you want. Well, you're going to get only those results back. And that's going to be a minute amount of data compared to what it would mean to bring all that EDR data into it. And again, that is for addressing, I would say, egress charges is the main thing that will make your life a lot easier. And also from the performance standpoint, if I'm going to be using all that chunk of data, why do I want to move it from one place into another and duplicating the data here and there? Again, that is from the search perspective, and this is my personal view. I'm not representing anybody on IBM here to the things. This is my personal view on what do I think that this vision of login sites is actually the right one, and it's the way to go for QRadar to evolve.